Okay, so we're making stem plots. Stem plots are a quick, easy way to get the shape of a distribution. That's the whole purpose of it. Um, it's like a histogram, only it works really well for small data sets. You don't lose your data. That's why we use them. That's why John Tukey, who you'll read about in Lady Taste and Tea, and developed these. So I was looking at the set of data. This is from question 1 on section 2.3 out of the textbook, and I noticed the smallest value was 58, the biggest value was 94. So that meant I could use stems for the tens digits, and I went through 5 through 9, and I'm just going to go through and fill out this table. So I got an 80, so that goes a 0 next to the 8. 79, I'm going to put a 9 next to the 7. 89, I'm going to put a 9 next to the last 0. And this is what I do. I just start filling it in. 67, 79, 93, 70. Actually, I get two 70s, so let's go 0, 0. I've got a 76, 88. Notice I'm not worrying about putting them in order. 73, 81, 79, 80. I'm also trying to use the same amount of space so I don't give a false picture of what this graph looks like as far as the shape. There's another 9. Then I've got a 58. I've got a 93, 94, so 93, 94, and then a 74. So what's the shape? So the whole point of this was to figure out what the shape is. Well, I don't know, maybe this is left skewed. I mean, I get those small, the 58 and the 67, and it's certainly unimodal because I've got that one big long stack of 70s. So the mode is someplace in the 70s, maybe I shouldn't word it that way. Well, actually, it is. The mode would be a 79, wouldn't it? Because there's 4 9s. So one thing you can do with a stem plot that's quick, that's easy, that sometimes clears it up, it's called split your stems. And what you do is you just write each stem twice. Hopefully I've got enough room to do this. 8, 8, 9, 9. Well, I don't have any 98, so I'll probably be okay. I've got a little piece of a menu item in the way, so I can't do that. Now I don't, and then what you do when you're splitting the stems, I'm going to put 50 to 54 here, 55 to 56 here, 60 to 64 here, 65 to 69 here, 70 to 74, 75 to 79, and so forth. So I'm just going to start filling this in. I'm going to put the 58 in that second one, because remember this other one's 50 to 54, and I've got 55 to 59. So same thing with the 60. I don't have any. 67 isn't between 60 and 64, so I'm going to put the 67 down in that row. And now I'm going to look at all these 70s, and I'm counting 1, 2 zeros. So in this first row of 70s, I'm going to put the 7. I put the zeros, and then I've got 1, 2 3s, and then I've got 2 4s, and then I think I'm up to my 6s, so I've got a 6 going to go down in the next row. Then I've got 1, 2, 3, 4, 5 9s if I saw this right. And I've got, for the 80s, I've got 2 0. That's a 0. Yep, so 80. 3 80s. I've got a 1 and I've got a 3. Then I'm going to put the 5, 8, and 9 down in the next row. 5, 8, 9. 8, 9. And then I'm going to go 3, 3, 4. So now, to me, this looks a little more clearly that this is a left skewed distribution. Yes, there's this little tail off to the right, but I would say these numbers here are going to have a lot of effect on any kind of measure, any kind of calculation we do. We're going to learn in chapter 3, we're going to learn how to use the mean and the median to determine skew also. So right now I'm going to call this a left skew distribution. That's what I think it is. Okay, so that's how you do it. I hope this is what you needed.